Welcome to this session. In this session, we state and prove the extension of the Cauchy's theorem to multiple connected regions. So let's give the statement and then we'll prove the theorem. So the statement is that if f of z is analytic in the region R, between two simple closed curves, C1 and C2, then the integral of the function f of z dz along curve C1 is the same as the integral along C2 of the same function f of z. So that's what we have. So let's provide the proof of this statement of this theorem. Now to prove, let's give a sketch of the curves C1 and C2. So consider the diagrams below. So the first diagram and then is the direction. So this is the C1, and then this is the C2, and this is called this point A, call this B. So this diagram A, and let's consider another diagram here. So this is the direction. So we call this one C1, call this one C4, call this one C2, call this curve C3. So let's call this diagram B. So the integral of f of z dz is equals to 0, where the path of integration is along, so we are considering this diagram given in A is along AB, this direction, and curves C2 in clockwise direction, and along BA along C1 in anti-clockwise direction. So that's what you're saying. So the integration of the f of z is equal to 0 where the path of integration is along AB, this direction, and curves C2. This is a curve C2 in the clockwise direction, and along BA. Now, when you reverse the direction, you'll be moving along the first curve, this C1, in the anti-clockwise direction. So the integral direction AB of f of z dz minus integral along C2 f of z dz plus integral along BA f of z dz, and then plus integral along C1 f of z dz is equals to 0. Now, so and clockwise direction is positive, then clockwise direction is negative. That's why you have negative sign on this along C2 and positive sign on C1. Then this implies that the negative integral along C2 of f of z dz plus integral along C1 f of z dz is equals to 0 because integral along AB f of z dz is the same as the negative of the integral along now the opposite direction BA f of z dz. So this integral here and this other integral here are canceling out because they are negatives of each other. So that's the reason as to why we are saying that this equation reduces to negative integral along C2 of f of z dz plus integral along C1 of f of z dz. So i.e., now taking this to the right hand side, we'll have integral along C1 of f of z dz is given by the integral along C2 of f of z dz. So this was the result that we were to prove. So the proof of this one actually is using the diagram in A. But then in this diagram in B is just to show us how to get or to compute the integral along a region defined by more than 2 curves. So that is a result of the corollary of this theorem. So corollary that the integral along C1, this curve, now I'm referring to this diagram in B, this curve C1 of the function f of z dz is the same as integral along C2 of f of z dz plus integral along C3 of f of z dz, and then plus integral along C4 of f of z dz. So just the sum of these sub curves that actually joins to form this C1. So along integration along C2, and then integration along C3, and then integration along C4 gives you, assuming that this is the starting point A, and then this is the starting, this is the end point B. So you see B, so this from A to B, this distance here. So move along this curve, move along this curve, then move along this curve. So you have covered the end point of C1 to the starting point of C1. So thank you.